Hello everyone, this is Professor Suraj Patil, and today here I will explain the introduction of nanomaterials. We know that nano means in the scale of 10 raised to minus 9 centimeter meter. So nanomaterials are the very small materials. Those material shows some different property than our regular bulk materials. So that we introduce the nanomaterials in short this PowerPoint presentation. Let we'll start with this nanomaterials. What is this nanomaterials? Basically, nanomaterials means the substance for which the scale is in nano. That means up to 100 nanometers range. The materials are known as the nanomaterials. That is one of its dimension is in the range of nanometer. So that material is known as nanomaterials. That we can see here top down and bottom up. These are the two important methods by which we can obtain the nanomaterials. See, by top down approach, we can obtain the nanoparticles or nanomaterials uh, as we can see here. There is a bulk, and if we cut or if we make a small particles pieces, and we'll obtain the nanomaterials or small scale materials, or bottom up approach. In this bottom up approach, we'll start from the atomic or molecular scale, and from those atoms or molecules we will obtain the nanomaterials. These are the two basic uh, methods by which we can obtain the nanomaterials. So let we discuss its classification of nanomaterials. So basically, depending upon the size and shape, nanomaterials are classified as zero dimensional, one dimensional, two dimensional, and three dimensional. In case of zero dimensional particles, for example, nanoparticles, nanoclusters, and quantum dots are also comes under the category of this nano zero dimensional materials. Now the next is nanorods, nanowires are comes under the category of one-dimensional nanomaterials. Then two-dimensionals are the thin films and nano coatings, and this is the bulk. We know that the three-dimensional bulk materials. Now, another thing, the important thing is that now what is the difference between the bulk material and the nanomaterial? Basically, what change occurs from bulk to nano? So we can see here electrical property. There is a change in the electric property, optical property, magnetic and mechanical property. These properties will changes from bulk to nano. These properties of nanomaterials are size dependent. In case of nano, the properties are size dependent, and in case of bulk, we know that properties does not depends upon the size of a material, but as we go at nanoscale, the property becomes the uh, size dependent property. So everything, electrical, optical, magnetic, and mechanical, all properties will be changed at nano level. So this change occurs here at the nano materials. For example, at bulk level, the electrical conductivity is different, and if we drop its size to the nano level, its property or electrical conductivity will change. So these are the changes when we go from bulk to nano. Now why property changes? Now why this property gets changes? There are some reasons. First one is the quantum size confinement effect. In the next slide we understood what is the size confinement effect. The increase in surface to volume ratio, as we go to the nano level, the surface to volume ratio increases, and for that reaction rate increases, and so many things are there. Next is a critical length scale. What is this quantum size confinement effect? This is the quantum size confinement effect. As we go to the nano level, the energy level, the spacing increases uh, as we decrease the size of a material. This is known as the quantum size confinement effect, and we observe this when the size the particle is too much small, which is to be comparable to the wavelength of the light or wavelength of the electrons. So this is the quantum size confinement effect, that is, as we decrease the size of material, the spacing between the energy levels goes on increasing. This is the quantum size, and because of this quantum size confinement effect, we observe the changes at nano level. Now this is the diagram which shows the quantum size confinement effect. As we decrease the size, we observe the spacing between the energy level goes on increasing. So in this way, you can see here the bulk band structure, and as we increase the its size, we observe the separation between the energy levels goes on increasing. Then quantum dots is a special type of the quantum materials. Here, it is a zero-dimensional particles, nanoparticles, having the size from in the range of 1 to 10 nanometers. The main important thing is that its size is comparable to the wavelength of the electron or wavelength of the light. Then the next is how discrete size and quantized energy levels. So this is the basic information about the quantum dots. And now the applications. So we can tune the electrical or any property by varying its size. By tuning its size, we can vary its electrical and all the property. So nanomaterials have great applications in a variety of the subject plant subject. So there is an example that as we change the size, the same CDS particles changes its color. Here we can see 2 nanometer, 3 nanometer, 4 nanometer, 6 nanometer. As we change the size of the material, we observe that there is a change in the color. So this is about the nanomaterials, and thank you much. I hope you understand in this small video. Thank you.